Hello and welcome to the 2021 IPB Tech Talk featuring Prosperity. As we know, the majority of dietary proteins are not fully digestible by poultry, and that there's an economic benefit in recapturing dietary costs by targeting undigested proteins with an exogenous source of protease. However, dietary proteins are diverse, and a broad spectrum protease is required for significant substrate hydrolysis. Prosperity is a multi-component protease supplement designed specifically for monogastric diets with poultry species in mind. The product is intrinsically heat stable up to and exceeding 85 degrees Celsius. It has a low inclusion level, is available in dry and liquid formats, and is highly flexible to multiple ingredients, including corn, hard grains such as wheat, distillers grains, oil seeds in their meals, as well as a number of non-traditional ingredients such as feather and copra meal. But what exactly is a multi-component protease? A multi-component protease is a product comprised of multiple strains, each strain being chosen based on their specificity and binding affinity to both plant and animal origin protein substrates. Prosperity contains significant levels of acid, neutral, and alkaline protease activity. The reason for this is to maintain high protease activity throughout the entirety of the gastrointestinal tract. The product also contains broad-spectrum endo and exopeptidase activities, allowing for superior amino acid liberation and large protein hydrolysis. Taken together, this gives Prosperity formulation flexibility and can be used in conjunction with other enzyme technologies, such as phytase and NSPases. A number of in vitro evaluations were done in the development of Prosperity. Chief among those was what we call the FAN assay. FAN stands for free amino nitrogen. And in this assay, which is controlled for temperature, pH, and time, individual feedstuffs are added into the assay in order to evaluate how a protease enzyme releases proteins from the substrate. Samples are collected every 60 minutes, and from those samples, amino acids and small peptides are measured as an indicator of protein hydrolysis, which in turn is related to digestibility. At the end of the assay, the higher the FAN number, the greater amount of protein that was liberated from the substrate and in turn is available for animal absorption and growth and performance. In the data set we're going to show here, Prosperity was compared to 3 globally available competitor products, all of which are single component or single activity protease products. The substrates evaluated were soybean meal and feather meal. You can see here a typical FAN assay output. In this case, soybean meal. Along the horizontal, you can see time marked out by hours, and along the vertical, you can see the FAN output. Prosperity is labeled in the dark green bar. And as you can see, at each time course, Prosperity had a greater FAN number than the competitor products. What this means is that Prosperity, when subjected to soybean meal, releases more amino acids and small peptides, and therefore is superior to the single compartment competitor products in releasing protein from soybean meal, and therefore is a better option for improving soybean meal digestibility. When we look at feather meal, we see a similar story. Again, across the bottom we see time, and on the vertical we see our FAN output. Prosperity is labeled in dark green. We can see at each time course, Prosperity gave a greater FAN release or greater FAN number than the competitor products, indicating its greater affinity, greater ability to release protein and amino acids from feather meal. To summarize our in vitro results, we can see that Prosperity had substantially increased the levels of free amino nitrogenous nutrients. This means that Prosperity will be able to release these nutrients from the substrate and make them more available for digestion by the animal. In addition, Prosperity should be able to help liberate protein bodies that are resistant to proteolysis within the gastrointestinal tract. Clearly, Prosperity is effective on both animal and plant origin proteins. Thus, Prosperity has the potential to improve protein digestibility and growth performance in vivo. However, in addition to improving nutrient digestibility, Prosperity has also been designed to deactivate anti-nutritional factors found in soybean meal. These specifically are trypsin inhibitors. Trypsin inhibitors are compounds found in soybean meals that reduce trypsin, which is a natural protein digestive enzyme secreted by the animal. Inhibiting trypsin results in digestive disturbances, reductions in nutrient digestion, and impedes growth. Historically, soybean meal, when oil is extracted, heat is applied. This heat that's applied to the soybean meal inactivates the trypsin inhibitors. However, with different forms of soy, such as extruded or expeller pressed soy, these trypsin inhibitor may be residual in these products, and therefore heat may not be applied to inactivate them. So, an exogenous source of protease, such as Prosperity, may have the ability to inactivate these anti-nutritional factors and improve the feeding value of these ingredients. What we see here is an output from a trypsin inhibitor activity assay. Along the bottom, you see the different treatment groups: control, 2 doses of a single compartment protease, as well as Prosperity at 125 and 250 parts per million. On the vertical, we see the amount of trypsin inhibitory units measured in each of these treatment groups. This assay was run for 5 hours at 40 degrees Celsius, with each of the various treatment groups included. We can see from a single protease treatment at either 125 or 250 parts per million, there was a numerical reduction in trypsin inhibitor activity, but the use of Prosperity reduced that level even further. It should be noted that raw soybean meals were used in this assay, and that conventional soybean meal has a recommended maximum trypsin inhibitor unit level of 5, and that the use of Prosperity reduced this number to a level approaching that maximum TIU recommended level. When we look at in vivo validations taken together based on the results of what we see both on nutrient release in vitro and trypsin inhibitor activity deactivation in vitro, we ran the following study, which was one of the first studies run with Prosperity. This was a very simple corn soy ration into which a 10% inclusion of a protein blend was added. There were 2 different diets representing 2 different treatment groups. The birds were housed in cages for 21 days, and at the end of the study, apparent ileal nitrogen and amino acid digestibility was measured along with growth performance. Although there was no effect of Prosperity on growth performance, what was observed was a significant increase in lysine digestibility. As you can see here, 89% with the Prosperity versus 85.9 on the control. In addition, numerical improvements in nitrogen, methionine, threonine, and arginine were also observed. This led to the conclusion that Prosperity has a protein-sparing effect, i.e., the addition of Prosperity into the diet spared protein and allowed for amino acids to be released from the feed, therefore improving digestibility. When the results of this study were applied to a follow-up study using more animals, 400-day-old Cobb 500 male chicks, in floor pens for 35 days using the following treatment, we found measurements of body weight, average daily gain, feed intake, and feed conversion. Treatments were arranged such as a corn soy-based diet, including feather and copra meal, which included phytase, and Prosperity was added to the control diet at either 125 or 250 parts per million and compared to a 200 part per million alkaline protease. As I mentioned, corn, soy were the predominant ingredients, along with feather and copra meal. These were protein-sufficient diets and were isocaloric across each phase. At 35 days, there was no effect on average daily gain or average daily feed intake, as can be seen here in the light and dark green bars. However, at day 35, it can be clearly seen that a numerical increase in body weight gain was observed when Prosperity was supplemented at either 125 or 250 parts per million. Most important here is that in these protein-sufficient diets, 250 parts per million of Prosperity supplementation resulted in a significant improvement in feed conversion compared to the control, and that this level of feed conversion was equivalent to the globally available alkaline protease product. To summarize the outputs of these in vivo studies, Prosperity improved feed efficiency when broiler chickens are fed protein-sufficient diets. This is contrary to previous studies that suggested that protease supplementation only would be effective when diets were protein insufficient. It should also be noted that the current studies demonstrate the protein-sparing effect of Prosperity, which enhances nutrient availability by targeting these undigested proteins, which in turn improves performance and profitability. It is important to note that the studies indicate that Prosperity can be used in conjunction with phytase, which is again contrary to previous studies that suggested that the use of exogenous protease products may actually mask the effects of phytase or even NSPases. Based on the studies presented, it is clear that the maximum improvement in feed conversion was achieved when diets contained 250 grams of Prosperity. In conclusion, from the studies presented, Prosperity improves the digestibility of plant and animal protein sources, increases the bioavailability of essential amino acids, minimizes the negative effects from anti-nutritional exposure, and together improved animal production performance and reduced feed and production costs. Please talk to your nutritionist or feed representative about Prosperity for your poultry feeding program. Thank you.